Did it make sense though when you tried it? Yeah, it's just the numbers were off. Okay, I'll do this anyways. It doesn't matter. 57. Here we go. If you didn't do it, here you go. So Aiden and Belinda are hiking. Not always will I give you diagrams, so just be careful. Just be ready for that. They're hiking when they notice people rock climbing on a cliff nearby. So Aiden, Belinda, right? They're obviously not in the same spot. They're some distance apart. They want to estimate the height of the cliff. Aiden estimates that the angle of elevation to the top of the cliff from his location is about 35 degrees. So angle of elevation is always measured from the horizontal going up. So this is 35 degrees. Okay, it's always 35. Can I just say something here? Angle of elevation is always the acute angle. Acute angle. You're like, why are you saying that? That doesn't make sense. Yes, just so you know, at this location, there's an obtuse angle here, and this is the acute. These are supplementary, right? They're next to each other. But angle of elevation is always the acute one. We don't want to use this one. So if you're not sure where, it's always going to be the acute one. Next, Belinda is 15 meters closer, so you fill this in. 15 meters closer, that's Belinda right here. She estimates the angle of elevation to be 50. So this is what we're talking about here. That is 50 degrees right there. Okay. All right. Determine the measure of angle ABC. Do you know how to read that? Right. So you just go ABC. So it's as if you're making that angle. So it is this one they're asking for. Okay. You can call this I don't know what letter, K. Right, so you can call this a little K here. And so angle ABC or angle K is going to be 130, right? I wonder why it changed it. There must have been a reason for it. Anyways. And angle C, that's right now, that's just up here, right? So we can also figure that out because once we've got this as being 130, we've got two angles, we can find the third one. This is sum of triangles, okay? So that is what, 15? 15 degrees. So you know that this is 15, you start filling that in. Calculate the height of the cliff. The height of the cliff, by the way, folks, I know it's all like, it's not straight here, but you might want to add a dashed line that indicates that this is the height. Okay, so we want that. How can we do it? We obviously going to have to work with this, either this triangle, because that involves the height, or this big one here. What do you need to find the height? You need a slant. You need a diagonal. You choose. Do you want this one or this one? That's up to you. How about we find this one? I'm going to call this X here. I'm going to find this one first. So how do we do that? Well, sine of 15, right? This angle here is across that side there. So they're both 15, so that's interesting. So we're going to go sine of 15 degrees over 15 meters. And then we're going to go sine of 35 over x. They're both in the same triangle. That's something that I noticed yesterday while you were working. You got to make sure you're in the same triangle. You're pairing up things in the same triangle, inside the same triangle. I'm in this one right now. Okay, so 15 times that divided by sine of 15. And I have to redo this apparently. What is it? 33.34. Okay. Sean, is that what you got to? Anybody solve for this side? You could have gone sine of 130 and solve for this side, because then you're going to move on to this big right triangle here. Right? So you could have done it that way as well. So now the height is going to be 33.34 0.24. I don't know if you remember the shortcut, right? 33.24 times sine of 50. Like you got to go sine of 50. Okay, I'll just finish it. 2546, yeah, thank you. Meters, so this is the ultimate question there. And let's say you forget the shortcut. Let's say you're drawing a blank 3 months from now, you're like, I can't remember the shortcut, I didn't put it on my study sheet, I'm stuck. No, you're not. You just draw your right triangle. You know that this is x, which you just found is 33.24. That's across from the 90. So you've got a pair there. And then this 50 here will allow you to solve for h. So if you think about it, you have a pair sine of 50 over h. You're going to end up getting the exact same answer there that you just found. So this is just a shortcut. Okay. Keep going. What else is it asking for? How far from the base of the cliff is Belinda? So it's asking for this here. So we can call that y, or whatever letter you want to call it. I don't know how I solved it on the answer key. Could you use Pythagorean theorem? It's a right triangle, right? It is a right triangle. You know 2 out of the 3 sides. So you could use Pythagorean theorem. I think I probably would have used sine law here. That's what I'm guessing on the key. So to not throw you off too much, right? This is 90, 50. If this is 50, then this is 40 up here. This one here is 33.24. That's my pair that I'm going to use. I'm going to stick with that one. The 40 is going to give me this one down here. Okay, so that's how I'm going to pair it up. So sine of 90 over 33.24. And then it's sine of 40 over y. So just thought of a joke. I'll finish this and then I'll tell you that. Okay, 32.24 times sine of 40. Oops. 2137. 2137. How about if I use Pythagorean theorem? I just want to know, I just want to explore my options. Y is a leg, correct? One of the legs. This may not work out because it's not drawn to scale. So this may not, but this is one of the legs here. So the formula that I gave you is that leg is equal to hypotenuse squared minus the other leg squared. Maybe don't write this down just yet in case it doesn't work out. Hey, we got the same answer. Okay, so this is using Pythagorean theorem. So it still works with right triangles. So that's kind of cool to see that. How far from the base of the cliff is Aden? This one is not too bad, right? We just add y and 15 together. So I guess this would be, yeah, I'll just show this. 15, sorry. That is 36, 37, right? Those are the numbers updated. I'll update my key then because I didn't realize that I changed the numbers on that. Okay. Any other questions before I continue? 58? Let's do 58. If you're careful how you pair things up, this is actually quite fun. If you mix up triangles, that's when you're going to be in trouble. Okay? Let me explain this one more time. If you go 90, right? You go 90 over this side, and then all of a sudden you use this angle up here and just the short side, right? You're dealing with two different triangles. You're in a small one and the big right triangle. So then you're in trouble. So you got to stay within the same triangle for this to work. Okay, let's do one more. A lot of sine law here, as you can tell, but don't forget about cosine law. It's still there. It's still with us. A radiator tower is stabilized by two guy wires. Did I tell you what guy wires are? Because I'm also doing trig in my other classes, so I'm a little... Guy wires are just supports. Two wires are attached at the same point on one side of the tower. Almost ignore this sometimes. Ignore the picture and just try to paint the picture in your heads. Okay? And they're 4.6 meters apart. So we know that this is 4.6. The first wire is 9.2 meters long. It's already there. The second one is 6.8. Okay, so A, at what angle of elevation is wire 1 installed? So we want this one first. So let's call that W. W1, like that corner right there. What law could I use to make that happen? Cosine law, right? Side, side, side. Side, 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 cosine law. Okay, so cosine of W1. How does this go again? Plus, minus. So I'll put the side that's across the angle I want is 6.8 squared. And then the other two sides go here, fill in the rest of the space. This is 4.6. So it's 2 times 9.2 times 4.6. I have anger issues, I think. I'm breaking the... Just relax. It's just math. Okay, we're going to survive this. So this gives you 59.56, and the bottom is 84.64. That in turn gives you 0.7036, keeps going. If you don't get a 0 in your leading number, you're going to be in trouble. You're going to get math error, which means you probably did something wrong. Maybe you forgot to square. Maybe you forgot to subtract. I don't know. Something went wrong, okay? So angle W1 is cosine inverse of that. And that first angle is 45.28. And there you have it. Crossed out some of my work. Not the best way to do math. But so that's that angle of elevation up there. If you have a highlighter and you like highlighting, right, this is that angle right here. The angle of elevation of the first wire. How high up the tower are the wires attached? So we want to know essentially the height of the triangle here. Mr. Erickson, there's more than one triangle. What are you talking about? Yeah, sorry. So this is what I'm talking about. This is what we're after. Not the height of the pole or whatever, the tower, it's the height at which they're attached, right? So can we do this? Absolutely. Watch this. You've got this diagonal that is touching the pole, right? And so we've got this big right triangle and we've got the angle here. So this diagonal times sine of this angle right here. Slant times sine sine of angle. So if you don't know which one I'm talking about, I'm just going to sketch this here. This is 9.2. This is 45.28. And this is height. So you go across, this is your pair, and this will give you the height, but this is just a shortcut. So the slant is 9.2, sine of 45.28, and that's 6.54 meters. Could you have used, if you just look up here for a second on the screen, could you have used this diagonal? In theory, yes, but we don't know this, right? So this slant touches that angle, but we don't know what it is, so I'm not going to use it in this case. Keep going. How far from the base of the tower is wire 1 attached to the ground? How far from the base of the tower is wire 1 attached to the ground? So essentially, we want to find out, this is the base of the tower here, so from here all the way to there. That's what it's asking for. So we're going to figure that out. There's a number of ways you can do that. I'm going to focus on the big one here. This is a 90. This is 9.2. Okay. We know this one here. This is 6.54. And we know this angle at this corner, that's 45.28. Right, this is the orange one that we solved right at the beginning. So if you want to highlight that, it's the same one. So you have a couple of options here. This is what we're after. Let's call this X. Okay. Like we want the whole. This is wire 1, by the way. If you're copying this, that's wire 1. So you can use Pythagorean theorem. Did I use Pythagorean theorem on the key? I can't remember. Maybe. But you can use pair and then use this angle to solve for that side. So we can actually say this is sum of triangle. So that's 180 minus 90 minus 45.28. I think I used Pythagorean theorem. So that's 44.27. Very close to that one. Okay, so now you know this one. So that's going to allow us to solve for that one. So I'm going to go sine of 90 over 9.2, and then sine of 44.27 over x. So you cross multiply and divide. That's 6.42. Wait a minute. My key is wrong, right? I'm just looking now at my key here. It says 1.86 on my key. This is what it should be though. And what I did wrong, I look at my key right now. My key is finding this, watch. Yeah, but my key is finding this here, from the base to wire 2. That's not what the question is asking. It's asking from the base to wire 1. So it's 6.42. That's what it is. So what I need to do with my answer, the original answer key, is add the 4.6 to it, and then we're going to be okay. Yeah, that's what I need to do. All right, D. I still need to figure out what D is here, way up here. This one, the angle of elevation of wire 2. So that gets a different color here. That's this one. There's a couple of ways of doing this. I'm trying to think how I will go about it. You can perhaps just stick to this triangle here because you've got a pair and you have the height. That's going to help you find the angle. Okay, so let me just sketch this out. This is 6.8. This is unknown here, so we can call this W2 at this corner here. This is a 90. The height is already known to us. That's 6.54. So you've got your pair, and this side is going to allow us to solve for W2. So we're going to go sine of 90 over 6.8, and then sine of W2 over 6.54. There are a number of ways of doing this, by the way. 6.54 times sine of 90 divided by 6.8. I'm going to run out of room here. Sine of 90 is just 1, correct? So I'm going to skip that step. I'm just going to divide this by 6.8. That's 0.961, and that keeps going. So angle W2 is sine inverse of that. Uh-oh. If you ever see this, folks, syntax error is you typed it in wrong. You can quit, but I usually try go to. It usually tells you what it doesn't like. So for future reference, that's what I do. So I enter. Oh, okay, it doesn't. I didn't give it anything. So I need to copy paste, right? I need to copy this into it. And then it's 74.10. That is the pink angle right there. So I'm just going to highlight that. It's easy to see. Fun stuff, eh? Yeah. Is there a different way of doing this one? Think about it. You could have used cosine law on this triangle here. That's an SSS to solve for this angle. And then what you do with that angle? You subtract that from 180 to get this one. So a lot of ways to get there in this case, right? Not always, but in this case. All right.